Good afternoon. Our next talk is Designing Poetic APIs by Erik. Erik works at Mozilla and by his own account writes way too many Python libraries. Please give him a warm welcome.
Wow, thanks for packing it out in here, guys. This is fantastic. Well, today we're going to take a look at psychology and anthropology and the history of our own field, and hopefully figure out how to write more beautiful APIs. So before we get started, I have a confession to make, which is that I am not a poet, unfortunately, I know. But poets and programmers, we have a lot in common. We both deal with very precisely formulated language. And we both make up new terms. In fact, programmers do this all the time. Whenever you name a variable or coin a new function, you're essentially making up a new piece of language. And it's this invention of language and the mental processes that go on with it that are key to writing excellent APIs. It's vital that we create new language with care, because the language that you use influences the thoughts that you can think. Have you ever had anyone tell you, you should go learn Lisp and go learn Haskell? It'll change the way you think about programming? Yeah. Well, there's something to that, as it turns out. There's this old psychological theory called the Sapir-Whorf hypothesis. And how it goes is, the language that you speak determines and limits the thoughts that you can think. And Sumana is shaking her head there. Yes, it has fallen out of fashion lately. But there was some evidence, or at least anecdotes, in its favor for a while. For example, take the case of Ildefonso, a Mayan man who was born deaf into a poor family, and so they didn't have a lot of resources to invest in things like sign language training or lip reading. And so he was actually brought up without language. He didn't acquire language until he was 27 years old. And during this early period of his life, he couldn't do math with quantities beyond 10, for obvious reasons. But now that he has the language for it and he's received training, he can do just fine. He can calculate with the best of them because he has the language for it. Now, so this strong Sapir-Whorf hypothesis, which I'm still getting bitter looks from Sumana about, has been disproved by counterexample. And you can actually do this just as a thought experiment. Here we are in Montreal, a bilingual city, and satisfying translations are possible. When I came into the airport, I wanted to grab a sandwich. I got in late. I went to Subway. The guy who was making my sandwich spoke French, I spoke English, we used French words and English words, and regardless of the language we used, I would have gotten the same sandwich out afterwards. Wittgenstein writes some pretty down and dirty philosophy. Now you can translate that very precise German into English, and the arguments still make sense, or at least the same amount of sense they did before. But there's still a flavor to each language, right? Who hasn't accused a colleague of, oh, you're writing Java in Python, knock it off. You're writing Python in standard ML. Python naturally makes you reach for hash tables. Functional languages make you solve things in terms of map and fold. In JavaScript, everything's a closure. And this is the weak form of the Sapir-Whorf hypothesis, which I dare you to say 5 times fast. And I think it does hold. The language that you use influences the thoughts that you think. Now I'm getting nods, thank you. So the bounds of this influence have been marked out experimentally. For example, in English, we don't have a whole lot of good words for colors in the red-orange range. Now, if you show an English speaker a bunch of color swatches, they can certainly distinguish between them visually. But if you then distract them with a card game or something and bring them back later, they won't be able to remember a swatch you asked them to remember if it didn't have a handy name in their language. So it seems that having a symbol for something, a word for something, makes it mentally lighter weight. When you draw a symbol like red over a bunch of details like, well, it's 630 to 670 nanometers of wavelength, it acts like a mental abstraction. You can kick all the details out of your head and save that mental space for higher level pursuits, like building sentences with the word red. Abstracting out symbols is the root of all human language. But it's also the root of all software engineering. Now, the point of software engineering, what differentiates it from just hacking around with spaghetti code, is making software intellectually intelligible by finding good abstractions. So let's talk about APIs. In creating an API, you make up your own symbols and their meanings, functions, variable names, data structures, and with the names and semantics that you choose, you shape all future thought about that system. Remember, Ildefonso couldn't get above the number 10 until he had the words for it. When you make a good API, you give those who come after you, including your future self, those numbers after 10, letting people think the thoughts that they couldn't before. For example, let's take a look at URLlib2 versus requests. Right. So URLlib2 is pretty horrendously verbose. It's hard to do common things. Part of that is because it has a greater scope than just HTTP, but I'm picking on it. Requests, a third-party library, has become a rapid de facto standard because it introduces this brilliant new symbol called the HTTP request. And I think this is even more brilliant because apparently some people have already heard of this abstraction and had it in their heads already. So one thing you can do is ask yourself, what would a naive user imagine my API should look like? If there are already existing symbols out there, just make them work. That's the easy one. Now, it's silly to try to turn good design into a process that you can follow or a formula you can apply, but I've gone ahead and taken a swing at it anyway. And there's some requests code for comparison. So today I'm going to give you 7 rules of thumb that you can use as a checklist. It may not give you good design for free, but it will guide you along and it will keep you from falling off all the worst cliffs. So the first principle is something not to do. Don't be an architecture astronaut. My first step in designing a new library is actually to not design a new library. It's all well and good to try to do good design in the abstract, but design is basically imagination, and imagination is little more than hypothesizing. And you know from history what happens when you hypothesize without continually bringing those hypotheses back down to earth and testing them against reality. You end up with alchemy rather than chemistry, right? It can be academically interesting, it can be visually impressive with lots of sparks and bright colors, but when it comes down to it, it's just a self-consistent system of nonsense, not of a lot of practical value. They didn't get any gold out of that lead. So to bring our efforts back and anchor them in the realm of science, remember that the best libraries are extracted, not invented. What this means is you should have 1, hopefully even 2, or as many as you can swing, applications that already do what your library is going to do. And then you take the bits of them that are in common and you factor them up into your library. For example, I wrote a plugin called Nose Progressive. Plugs into the popular test framework Nose, and its purpose in life is to display a progress bar and fancy tracebacks and just generally make output easier to grok. Now it makes use of a lot of terminal escape codes for things like colors and bold and positioning, and the code looks something like this. There's lots of terminal setup kind of intertwined with the operative code. There's lots of abbreviations for different term info strings. And there are raw term cap names like SGR0, not very friendly things, and RC that you have to keep looking aside to the documentation to figure out what they mean. Every time I'd have to do some formatting, I would think, boy, I wish there was a decent abstraction around this so I wouldn't have to look at it all the time. And this is the magic point. When you have a real useful program with a library struggling to get out, that you should come down from orbit and start thinking about library design. In this case, I ended up extracting the terminal handling into a library called Blessings, and I want to use it as the first example of our extraction process. So the first thing to do is dump everything out on the workbench. What sort of things ought the library to do? Well, we want to print some text that's formatted, and we want to print some text maybe at a location like at the bottom of the screen where the progress bar is, and then snap back to what we were doing up by the tracebacks. What tools do we have? Well, we've got everything that's native to the language. We've got functions with optional args and positional args. We've got decorators, those are fun, context managers, and classes will let you do inheritance. But we also have common patterns that come from the culture and from the things that the library encourages. Again, weaks appear wharf. Sequences that you can for loop around, iterators, and mappings. Then we shake the workbench up and we see if we can find some good pairings between these things. What guides you in this? Consistency. You have the entire technical and cultural weight of the language, as well as the accumulated habits of influential libraries and the programmer community behind you. When we're designing websites, we think of it this way. People spend 90% of their time on other people's sites, so yeah, put your logo in the upper left, make it link to your homepage. Put the login link in the upper right, call your shopping cart, not takeout basket, make your links blue, and so on. Now, when you're writing an API, you can use the same sort of thing. users spend 90% of their time calling other people's APIs. So if you have to, you can be weird and clever, but if you can stick with conventions, you'll get a lot of bonuses. First of all, you'll convey respect for your users. You're not some outsider who's going to come in and make their code a mess of clashing styles with bad case conventions and weird factorings. How many times have you encountered a Java API masquerading as a Python one and thrown it away in disgust? Second, you'll get learning speed and retention. If it's the same as everything else, there's less to learn and less to remember. This is the brilliant thing about the early Macintosh project. They had explicit written down human interface guidelines because very soon after hiring their first programmers, they hired a whole bunch of technical writers. Every program had the same commands: open, close, quit, copy, paste, and they all lived in the same menus and had the same keyboard shortcuts. So in a very real sense, when you learned one program, you had learned them all. Now, API design is the same in so many ways as UI design, and we can apply a lot of the same principles, like the principle of least astonishment. So try not to surprise the user. If you implement some kind of mapping type, and you have something that acts a lot like a Python mapping, you should call its get method get, and it should take key and then default. You shouldn't call it fetch and then reverse the arguments. People will pick it up faster and remember it better if you use just plain old get. Plus, you get polymorphism out of it, right? If you're consistent, things can kind of luckily happen to you, like, oh, I can just substitute a dict in for my Redis writing mapping class and use it to mock some things out in my tests. Or I can even deploy small sites just using a big RAM resident dictionary instead of talking over a socket and having that setup cost. So coming back to our terminal formatting example, how do we bang those tasks against our existing language features and conventions? Well, here, quantity over quality rules. And this is the same kind of rule of thumb I use when I'm designing UIs. Just get as many alternatives out there on the workbench as possible. And I call these my sketches. Now, for printing something at a location, there are really only two choices. Both of these are okay, but the second one gives us the flexibility of putting multiple statements inside, loops, even other calls out to other functions. And then you could easily write print at, the first one, in terms of the second one. So the second one is the winner. Here are the sketches for text formatting. We've got some square brackets in there, we've got some dots and some string concatenation, a couple of function calls with keyword arguments, some with positional required arguments. Now most of these separate the printing from the formatting, which is generally a good idea, but the first one combines them together. I have a couple of favorites here. There's this one. It gives you a very familiar nested function call syntax. It's composable, and frankly, it looks a lot like HTML, so probably familiar to a wide swath of your audience. The trouble is, there didn't happen to be a portable way of turning off bold in terminals. So that was kind of out. Now this just uses attributes and saves us a great deal of complexity. We didn't have to squirrel away state or have any kind of big stateful object we're dragging around remembering if we had turned on bold so that we can emit the code later. No, we just emit the exact terminal codes as attributes on a terminal class. Now, to support the nesting case, oh, I should mention, notice that I'm using this with Python's built-in template formatting syntax. So by being consistent with language features, we get this for free. We don't have to have our own templating language, which so many terminal formatting libraries do. Now to support the nesting case, we have this kind of mash it all together syntax, red bold, or we could have said red bold on white. Now admittedly, this is a bit novel, but I kept this example in the consistency section because I think it's really good to see that these principles are all about trade-offs. We can't just turn all the knobs all the way up to 11, or we would just do that all the time, and we wouldn't need to think about this at all, and I wouldn't be giving this talk. So if you're going to do something a little bit weird, at least be self-consistent. This mashed together multi-word syntax is used for everything in Blessings. Formatting, foreground color, background color. It's hard to get it wrong. You can put the formatters in any order, and it just works. And there's caching for speed, so you don't have to worry about using some favored representation. So the user doesn't have to keep on making trips back to the docs. They internalize one slightly weird idea, and that carries them through all of their use cases. Another really straightforward example of this is Django's ORM syntax. We've got those double underscores, right? Nobody else does that. But this is used consistently throughout the ORM. You learn it once, and you apply it everywhere. So when you're evaluating your consistency, watch out for these red flags. If you find yourself frequently referencing your own documentation or the source code of your library you've previously written, as you're building the stuff, hey, what did I call that? Did I put the arguments in this order or that order? Maybe you should go back and try to clarify things. If you feel like you're inventing novel syntax, make sure you stop and check yourself. Use your judgment. When you're doing novelty, make sure that it pays off rather than just shows off. Our third rule today is brevity. Try to make common things short. In tokens, I mean, but sometimes even in terms of characters if it doesn't hurt your readability too much. Here's our excerpt from earlier, and now we'll go into why we use this mashed together syntax a little bit more. Since formatting something and then resetting to plain text is the most common operation, we try to make it the shortest. Here's a shortcut, and these two lines are equivalent. You can actually use this as a string, like above, or you can just call it and it's equivalent. But not everything has to be brief. This, for example, is a way to get down and dirty and really control exactly the bytes that you're emitting. Now, most people don't need this. They can do the easier thing above. But if you want to get down and crazy and dirty, this lower thing lets you do it at the cost of just being a little bit longer. The general principle is you should pay for what you eat. Ask yourself these questions about brevity. Do you find yourself copying chunks of code from your examples? It's probably too hard to type that stuff. Do you find yourself typing something irrelevant and saying, oh, why do I have to pass true for this argument? It's always true. Why can't you just assume that? Well, that's a default right there. Another way this can manifest is very long argument lists. You could be missing defaults. Maybe you just have very complex data, and it'd be better encapsulated as a class that you can instantiate once and then call methods on. Composability. Making your abstractions composable means being able to reuse them in lots of different situations and plug them together in unforeseen ways. Now, there are a million ways to say this. Flexibility, loose coupling, small pieces loosely joined. It all comes down to the minimization of assumptions. Now, there are two ways that you can go about this, one of them wrong. Let's go back to another way we could have done blessings. We could have jammed together printing and formatting all in one go, like this. Now, my friend Jeff Quast put together a really neat bulletin board system called x84. It's really old school. It works over Telnet, and it uses blessings in a multi-process design. It's not like Apache. It's got a server process where most of the action happens, including the formatting, and then it doles out to children processes which handle each socket, each client connection. So with the first line here, there's no way to pass the output to the children. In fact, in either of these. First one, let's go with the first one. Because we assumed, and there's that coupling, that printing and formatting would happen all in one go. Now, the wrong way to solve this would be line 2, add an option. Say, pass in a file handle. But now, you've always got to instantiate some file handle or string IO object, even if you just wanted to keep that string in memory. Plus, it makes the API more complicated. You've got to document that option. You've got to put a branch in your code for it. And then you've got to write tests to test that branch. Every time I think about adding an option, I look around for any other escape route first. So a better way here is to break that coupling at the assumption point, dividing into two orthogonal pieces, print and format. Now, because we followed the composability rule of thumb in blessings like this, Jeff was able to stick formatted strings into memory really easily and pass them off to his child processes. And despite the fact that he started x84 10 years before blessings even existed and had made a lot of architectural commitments and decisions, it was a really easy retrofit because it minimized the assumptions it made. So watch out for these red flags in composability. Classes with lots of state make me think that there are multiple little classes inside just struggling to get out, each serving a single purpose. So the PyElasticSearch connection object is a library for talking to Elasticsearch from Python. And it needed a penalty box for Elasticsearch nodes that weren't responding. I didn't want to keep on trying these nodes if they weren't responding, give them 5 or 10 minutes to recover. Now, I was tempted to add this directly to the connection object, but I found out it was better, in fact, to separate them as a separate thing, and I can now reuse this in other projects. And this doesn't even assume that it's for connections. All it happens to have in it is URLs that represent the nodes. I can put ints in there. It doesn't care. All it knows is you give me a bunch of things, you tell me which ones are dead and alive, and I run a timer and give you one at random. Another thing to watch out for is deep inheritance hierarchies. People say, and they're right, that composition is better than inheritance. And here's why they say that. If you inherit, your object does get easy access to the functionality of the parent, and that much is true. But it also inherits all the invariant baggage that the parent has. And it's required to maintain those invariants. What you've done now is just increase the attack surface, if you like, the amount of code that has to tiptoe around those invariants. The law of Demeter. Now this says if you do choose to compose objects, no cheating. So if Elasticsearch contains a penalty box object, the Elasticsearch object can call methods on that penalty box, but it's not allowed to call methods on objects inside the penalty box. So think of it as the one dot rule. A.B is fine, A.B.C is less fine, A.B.C.D is right out. Because if you're reaching into everything like that, you're making assumptions all over the place, and there is no point in splitting up these objects to begin with. You might as well just all dumped it in one namespace. Mocking and tests. I'm of two minds about mocking. I think if you find yourself mocking out too many dependencies of your code has too many dependencies. For example, how would you test this? You'd have to reach into sys and mock out maybe standard out, and then you remember to put it back afterwards. You need a mocking library maybe to help you do that easily. On the other hand, this doesn't require any mocking. Just compare the return string and forget about printing. Testable code is decoupled code. And then finally, bolt-on options. Look out for those. Now another rule of thumb that helps with reusability is plain data, sort of native data types. Whenever possible, your API should speak with its callers using simple built-in types, dicts and ints and strings, not big hairy custom data structures. And the aim here, which should be sounding eerily familiar now, is to reduce barriers to reuse. What's a barrier? Well, a barrier is the config parser class out of the Python standard lib. And this is an excerpt of its API. Its purpose in life is to read Windows-style INI files. Now, unfortunately, config parser is not just a parser that does its job and translates the file into a string or a couple of dictionaries, nested dictionaries or whatever, and gets out of the way. No, it hangs around, and you have to write your entire program in terms of its API. You end up with has option calls and get calls all over the place. But they're not idiomatic Python things. Get, for example, it's not your normal get. It's section option, not key default. That's a little confusing. And you could imagine even has option, section option. We could represent this whole thing as a nested map, you know? Bracket section, bracket option, and away you go. Then later, if you want to make your program more flexible, maybe pull in YAML configuration or something else, you're still stuck to this API, right? You have to put ifs in your code each time you do configuration, or you have to write your own abstraction layer on top of this. So let me pick on this a little bit more and lie just a little bit about its API. We're going to say it has a read command, which it does, that takes a single file name, which it actually doesn't. This might feel like a convenience, since config often comes out of files, but actually, it's a barrier. A method should take what it needs and no more. You need a string. You don't need a file for any reason. The config file is not 500 megabytes. You're not going to be seeking around in it. There's no reason to need a file handle. Now, if you want to add the convenience back, that's fine. You can add a helper function like file contents that can be used in combination with this string-taking method. Or you can go ahead and add a convenience function also that does both parts, but make sure you also provide the core method that takes the minimum thing it needs. Even when you have an inherently more complicated data structure, try to expose as much of it as possible as built-in interfaces. This is a little snippet from a library that I'm working on called SpiderFlunky, and it does static analysis of JavaScript code. Now, I was ashamed to find in my travels that I actually needed a doubly linked tree to represent the abstract syntax tree. Singly linked wouldn't do it, so I couldn't just have nested lists. I needed to be able to walk from the inner lists out to the outer lists, or up the tree. So I had to make this node class, and it hurt my soul. But there you have it. But the first thing I did was to break back into the Python idiom by exposing things as kind of built-in language constructs. In this case, a transit up the tree as an iterator. Now, because I then exposed this as something that the language kind of gives preference to, I could do pretty complicated things with sexy little one-liners like list comprehensions and generator expressions. This finds me the scope of any JavaScript AST node, just by walking on up and taking the first one that looks like a scopy kind of node. So if you can't have plain data everywhere, get back to it ASAP. Plain data warning signs. If your users take your output and immediately change it to something else, you probably should have given them something else. If, conversely, you make them instantiate some massive custom object just to pass it to a routine of yours, well, maybe you should just take those individual things individually, unless you see them reusing them a lot, reusing the bundles. And then if you find yourself rewriting things that the language already provides in different terms, like config parser had that get thing that took a section and then a key, where it's really just one key access, two key accesses. So I have this idea that users of my APIs should spend most of their time in the groove. And I don't just mean performing well or doing their work easily. I mean it in a more strictly physical sense. So if you think of programming as walking like across a plane, and there's this groove in the plane, and it's a nice smooth path, and it has kind of curvy sides that tend to keep you centered in the groove. And you can even close your eyes and walk through it, because even if the groove is curving, it's got these nice, gently sloping sides that push you back into the center. So even if there's nothing keeping you from stepping out of the groove and walking somewhere else, the groove is very attractive, and new users are drawn there first. Here are a couple ideas on how to cut grooves in your APIs. Avoid nonsense representations. So let's talk about PyElasticsearch briefly again. There are two ways to query Elasticsearch. You can pass it a big JSON blob, very capable but complicated, or you could pass it this more limited but terse string syntax. There's no such thing as an Elasticsearch query that uses both formats at once, or neither format. You have to choose one. Now, here's what PyElasticsearch used to look like. All its args are optional. You have to pass in the string style queries using the Q argument, and the JSON ones using the body argument. Of course, this meant that nothing stopped you from doing this, or even this, both of which are complete nonsense. And I'd say you shouldn't even be able to get that far. You certainly shouldn't need code in your library to reject this kind of silliness, which we used to need. The new PyElasticsearch looks like this. We replace that mess with a single required argument to which you can pass either a string or a JSON dictionary. You can't go wrong because the interpreter won't let you. It's much groovier. Now, incidentally, this turns up another principle, which is to fail shallowly. In languages that give you tracebacks, this is a very nice convenience. But if, heaven forbid, you're using a language that doesn't, like a lot of JavaScript implementations, this is absolutely vital. And this is one of the things that drives me nuts about JavaScript's design. How undefines and nans can pop out of things and get squirreled away in data structures, only to appear 500 function calls later, and then you spend all afternoon trying to trace where these things came from. Fail shallowly. Another way to provide grooves is RAII. This is a poppable balloon class. But as you can see, when you first construct one, it has 0 air in it. Now, you can't pop a balloon that has no air, right? You might imagine seeing some documentation that says, before popping the balloon, make sure you fill it with air. Now, that's broken design. A poppable balloon class should be poppable all the time, full stop, right? The user shouldn't have to head over to the docs to figure out what went wrong. So a better way here is to require explicitness, which we know is a good thing because we're Pythonistas. A better way is to take the initial fill amount at construction. The user is required to provide it, gets an error if they don't, and so there's no wondering later on why the balloon just went squish when you pricked it. RAII is just a more specific case of don't have invariants that aren't. And then a final way of providing grooves is through compelling examples. Now these are the most overt sort of grooves. The user knows that they're being advised. This is a screenshot from Mac Paint 1.0. Who's actually seen this in the flesh on original hardware? Yeah, we got a lot of people as old as me in here. This is great. Palettes are on the left, menus are on the top, and it looks familiar to everybody in this room, even those who didn't put their hand up, because Photoshop and Illustrator and the GIMP and Pixelmator and PaintShop Pro and MS Paint have been slavishly following this pattern for the last 30 years. Another great example is Nintendo platformers, right? This is original stuff on this hardware. I don't think anybody had done anything like this before. But even today, we're still jumping and running to the right. If you set a good example, people will happily follow it forever. Now, I used to write my example code in really like didactic fashion, long, outrageous variable names, inefficiency for efficiency traded off for clarity. And I ended up having to stop doing that because what people were doing was they would take my code, the example code, and like paste it into the production systems, and they'd even leave the comments there out of the docs, even if they didn't apply anymore. So I had to actually drop down and realize that my users are docile. They will do exactly what you tell them to do. And it's not that they're not smart. They're just not interested in solving that problem that you solved. They want to get in, get the functionality, and get back to the interesting problem that they're trying to solve. So be a good library citizen. Give good examples. Grooviness. Yeah, so look out for representable states that are nonsense. You shouldn't even be able to state nonsense. Look out for invariants that aren't invariant. And watch new users and see if they don't know where to start. The tech writers in the early Macintosh project would often come back to the programmers and say, hey, you know, this UI is totally confusing. I'm having to write all this documentation in order to explain it. Bad design becomes obvious when you try to document it. If your API is too hard to explain, it's probably too complicated. So let's go back and fix the design. Incidentally, this is why I like to write the README first thing before I write any code. Documentation-driven design makes for a better UI. Now we get to the walls. Walls are to keep you from hurting yourself or others. Just as in the physical metaphor, there's a continuum between grooves and walls. The more damage you can do with a feature, the higher the wall should be, the more barbed wire it should have, and the meaner the dogs in front of it should be. Here is a horrible API with not enough walls. Does anybody see what's wrong with this? Maybe it's bitten you in the past. Who here has wiped out a whole database column because they forgot the where clause? Yeah, a lot of money wasted in this room. So one way we could have maybe fixed that is to require you to say all when you mean all. A little less mathematically elegant, but think of all the money and time and hair it would have saved since the advent of SQL. Here's another old chestnut. This is a pretty common thing to do, right? Trouble is, to do it, first you have to type this, which is seriously bad news. Don't hit return by accident. Now maybe we could require -F for this sort of thing. I think actually some shells have started doing this, which is fantastic. A very similar sort of thing happened in PyElasticsearch. This is what the delete method used to look like. PyElasticsearch can delete a document based on an ID, but one of its faults is if you don't pass an ID, it'll just delete all the documents. Thank you, very convenient. An ID here, if you'll notice, is optional. I mean, I can certainly imagine putting my end parentheses too soon or putting my ID in there, but I forgot one of the other args, so it turns out to be a doc type and not really an ID. So we fixed that, and here's how it looks now. ID is mandatory. Pardon me. And we introduced a separate delete all method for that weird case where you want to delete all the documents. So you can't possibly screw that up by accident. You can only screw it up on purpose. The other thing to consider is how to report errors. And you have two choices most of the time. And throwing an exception is a lot better than returning something. Because as we all know from C, it's way too easy to ignore a return value. Warning signs for safety. If you, back to the docs again. If you're reading your docs and you see that you're saying, hey, remember to, or make sure you do this, maybe you should make it so you don't have to remember to. Or if it's a make sure you do this before or make sure you do this after, consider context managers. That's a really great way in Python of wrapping things. Second, ask yourself, what's the most dangerous thing I can do with my library? And then make sure there are barking dogs in front of that. You can't do that by accident. Be aware that most people won't self-report safety issues. There's still a culture of blaming the user that goes on in programming. We have to work to stomp this out. So users are embarrassed and reticent to admit that they made what they see as a mistake, which is actually a design mistake, right? If you have an electrified doorknob, it's not that you didn't go get the asbestos mitt first, the non-conductive mitt. It's that you shouldn't have an electrified doorknob. What are you doing? So you need to actively watch out for your users and solicit mistakes people have made. Those are my 7 principles, and here I've compiled them into a nice little checklist. And if you bang your APIs against them while you're designing them, you should avoid the most common pitfalls. But let me get meta for a second. You may have noticed that there were no big black lines between some of these principles. They kind of bleed into each other. Like plain data helps composability, and brevity aids grooviness because it's easy to remember things. So I began to wonder, does any order arise out of the relationships between these? And it turns out that it does. If you lay them all out and you draw arrows between them that indicate this one contributes to that one, you see them kind of divide almost perfectly into 2 clusters. The left cluster is things that kind of evade a quantitative definition, compactness and grooviness. And these are more for human comprehension, while the things on the right are more calculable, things you could imagine having an absolute impact on the number of lines of code in the system, ignoring human comprehensibility. If you like, the left is lingual and the right is mathematical. Now, I've often thought that you can approach computer science from either of these directions, as if it's language or if it's math. I didn't even like math in school. I was okay at it, but I didn't love it. I still argue with people who say that programming is essentially math because I'm a lingual thinker. But both of these things are necessary to get anything to actually work, right? So this spotlights the things that programming languages have over ordinary human languages. Programs are alive. They not only mean things when people read them, but they actually do things when run. So very literally, a program with carefully chosen symbols is poetry in motion. Pretty neat. Thank you very much.
Mic is on.
There we are.
Sure. Your talk is good and you should feel good.
Thank you. Thank you. Glad you enjoyed it.
And I mean, basically you agree with my beliefs, so we must both be right, is all.
Speak slowly because it echoes all over the place.
Oh, okay. I'm just flattering you, that's all. I wanted to mention a couple of additional resources for
Please.
people who came out of this talk and said, where's more?
Good idea.
In the book, Making Software, What Really Works and Why We Believe It, edited by Greg Wilson, who's here, and Andy Oram, there's a chapter about API usability, and there's a chapter about what different languages cause people to think when trying to do the same exercise, what data structures they reach for, and stuff like that.
If you've got case studies, that would be fascinating.
Exactly. And your design philosophy seems to accord with that proposed in RESTful Web APIs, the book my spouse wrote, and How He Made Beautiful Soup, which I sort of watched him do. So thank you very much. I agree with all of your ideas. Thank you.
You're quite welcome. Thank you, Sumina.
Hi, Erik. Thank you. I just want to know what's the API for popping the poppable balloon?
What is the API for popping the poppable balloon? I suppose it would have a pop method. But if it was in Java, you'd construct a pin factory and then apply it to...
But if it's a pop method, then won't you end up with a poppable balloon that you can't pop anymore?
Yes.
That's representable nonsense.
Sorry, the echo is really bad in here. Any others?
So you said if you have to mark so many dependencies, you shouldn't have those dependencies? What if you have to have those dependencies? What if you have to have a whole bunch of dependencies? Do you still believe in mocking or not?
Well, if you, so this is a whole separate talk on testing. If you have to mock a little, then you have to mock a little. Sometimes you're limited by your framework and you can't refactor things how you want to. There's also a trade-off to be made in testing between what's an integration test and what's a unit test, and which do you value more. Myself, if I'm not making something super complex where I need those tests to prove things, to prove my way up, I'll tend to reach for integration tests first just because they do test the whole system. And even though they won't tell me specifically what went wrong if something breaks. And integration tests are often more coupled than unit tests and use less mocking.
I see.
So you could bend that way if you wanted to, just to avoid the mocking. But mocking is not intrinsically evil, it's a smell.
Yeah, I don't like mocking because things change that you mock. So your mocks could be old. But yeah, thank you. Your talk was very good.
Thank you for coming. Get right up to the mic.
Yeah. So I'm curious what you think from your lingual versus math sort of dichotomy on how you name classes or model things as real world-ish versus sort of more compute abstract and sort of the truck versus car class debate.
I like my code to read like it was English prose. And something I've started doing lately is instead of naming my functions after verbs, sort whatever, I'll start naming them after nouns. So, sorted, for example, is a good example out of the standard library. So that then I can just kind of read across and say, well, this is the sorted thing of the read thing and the stacked thing. The nice thing about that is it's consistent with the purpose of making functions and abstractions at all, which is to hide the details. I don't really care that it's doing a quick sort, I just want it sorted. The details might change later on, right? So, as far as naming goes, don't put anything in the name that isn't, that shouldn't be cared about at the call site.
So I know there are a lot of other kind of really good API design principles that I guess fall a bit more on the technical side, like no global state or inject your dependencies and things like that. Do you think those necessarily follow from these principles, or do you think they're kind of a separate set of principles?
Well, the no global state thing is a matter of decoupling. If you have global state everywhere, everybody's sharing it and they're coupled at that point. What's your dependency injection one?
Dependency injection, just the idea of pass things in instead of sharing them behind the scenes.
Again, that's the decoupling
which I guess,
thing.
again, is global state.
Exactly, yeah. Decoupling has its, tendrils in a lot of different places. You can see how it connects to so many different things.
Yeah. Cool graph, by the way.
Thank you. Give me my circles back.
I thought your point about the Elasticsearch API with the deletion was especially interesting, as if I recall correctly, the actual Elasticsearch REST API does require you to explicitly say all, doesn't it?
It didn't as of 0.9D point something or other. They might have fixed that in 1.0. That would be a breaking change. And that was a really good breaking change if they did it.
I believe they at least allow you to say all now.
They do that with indexes, I know.
I found that a interesting example of how you can sort of hang yourself by when translating between, as it were, different languages here. It looked like what had happened was that an API that was safe on one side had become unsafe by applying another language's principles to it.
Oh, really? I mean, in this case, we wrapped it with a safer API because it was just too
the
crazy.
original version, where you could simply provide a none and have it delete everything.
Yeah, I'm not sure if the wrapping introduced that. I mean, the original REST API was like that. If you type less, you delete more, kind of like the RM star thing.
Yes.
And now that you mention it, I do know that Elasticsearch 1.0 has the same problem with indices. If you say delete indexes and say nothing, it'll delete them all.
Oh, really?
Yeah, it's bad news. Now, there's a server setting you can set to not let that work, which I'm not going to set.
Well, I suppose that's the opposite of the question I was trying to ask, of the perils of translation, in this case, translation adding safety.
Yes. Add it when you can.
Which brings up another interesting question, actually, your mention of breaking changes. Like, do you think, how do you think change management in APIs fits into this framework? Is it like, is it mostly just a matter of like, I mean, I know there are some people who are advocating the philosophy of never break anything. But then there are some people who are, I like to do that voice, but or is it a matter of you have to balance whether it's a really big important change versus just a minor thing that say you realize later, I have a better way to do something.
Sure.
But it's not necessarily a dangerous thing like requiring a special delete all method. It's just a better way to do it.
But a breaking change nonetheless. Sure.
Nonetheless.
Yeah, compatibility is actually one of my skipped slides here that didn't quite make the cut. And compatibility, well, my basic philosophy is use semantic versioning, first of all, if you're really going to change something. Compatibility is a place where I can be prevailed upon to actually bolt on an argument. Now, if I've designed an API in a decoupled way, like I was going to have this Elasticsearch API that had a bulk index method, but then instead of taking a whole bunch of different options, I'd have a bunch of helper procedures which I could use to build a big data structure of bulk, many documents, and pass that into bulk index. Those things I could then obsolete individually and deprecate them and add new ones, and here use this one instead and pass it to bulk index without changing bulk index's signature. That's one way to do it. Through decoupling, again, everything's decoupling, right?
Okay.
The other thing is compatibility adds another dimension to this. It puts us in four-dimensional space. And so then you start thinking about coupling between time periods. And that I haven't thought about, but it would make a great talk.
So with the Elasticsearch example, how do you think about the trade-off between kind of having a more transparent layer between the library and the thing you're communicating with versus building up kind of your own API that more matches the language or your idea of how it should work, and then making a lot of translations between that and the service that you're talking to?
Exactly. Let's see if I can't find this as fast as I thought I could. Well, there is what you say, a very one-to-one API hiding inside PyElasticsearch. And let's see, send request. I guess I'm not going to be able to get that into the correct monitor. There is that thin API inside PyElasticsearch. The API that we then expose publicly, actually they're both public, but the one we advocate is a little bit more of a layer, gets rid of the dangerous things, puts some walls up. And then on top of PyElasticsearch, there are even friendlier libraries like ElasticUtils that let you do kind of Django ORM-like things under filter and that kind of thing.
I see. So the way around it is actually to build more abstraction.
Exactly. There's another skipped slide that I didn't have time for called fractalness, which I think an API should be usable at any level of abstraction you care for. Simple case is higher level, but you can drill down as far as you care to.
Makes sense. Thank you.
Sure.
Thanks very much, Erik.
Thank you. Thanks for skipping lunch.